So, hey guys, today's topic is the smart task prediction system. So, imagine if you work at a busy company and every single day your team gets hundreds of new tasks, emails, and messages, and they look like this. The login page is broken, or like, can we schedule a one and on meeting for next week? Or maybe, like, please send me the data analysis for the Q4 report, or something like based on urgency, that is urgent services now. So how does a team manager sort this mess, like who handles what and what's important, right? So then, like, a human needs to read every single one of the task and category, like, manually categorize it, and it's slow and expensive and boring, right? And as you can see, there is a standard machine model learning model is great at finding general patterns, so it can learn the task with words like broken that are usually verbs. But what if your company has a unbreakable rule? For example, if any task containing the word invoice must be classified as a billing issue, that means, like, with 100% accuracy for legal and compliance reasons. So an ML model might get this right 99% of the time, but in business, that 1% error can be very costly. So we need a system that has a general intelligence of ML for handling vague requests, but also the precision and certainty of fixed business rules for critical issues. So this is where a hybrid system comes in. So it gives us both flexibility and control. So as we can see, the key is that the rules engine gets the first look, right? And it acts as a fast, precise gatekeeper. And if it finds a match, then the process stops. And if it does not, then the task falls through to the more general ML model. So now we'll discuss about the rules engine, that is the specialist. So the rule-based engine. So think of this as a security guard with a very specific checklist. So how it works? Because it is just a series of if-then statements that we have the programmers write by hand. For example, if the task word contains the word urgent, then we can categorize it as urgent. And for another example, if the task description contains meeting or schedule, then we can categorize it as meeting scheduler. And the pros for this would be, like uh, it is fast because it is just checking for a word, and it is also transparent, like we know exactly why it made a decision, but because it's not a black box. And it is 100% predictable. And for this, as you can see, as stated, so like if suppose a task contains invoice or payment field, then they know instantly that this will task will go to billing. So this is how. And the cons for this would be, for rule based engine, would be like brittle, because what if someone types asap or critical instead of urgent, because our rule fails, right? They are typing an synonym, so we would have to manually add every single word. That means all the synonyms of that particular word. And it is not smart because it cannot learn, it just knows what we explicitly tell it. And scalability is there because it is impossible to write rules for every possible task. That is there. So now the component two is the machine learning model. So, how it works is, like, we don't write if then rules, but instead we show 10,000 past examples, our training data. So it learns the pattern on its own. For example, if it sees the task words like email, send, reply, or maybe campaign also. So they are often categorized as email. So what if it sees the task with data analysis report? They are often categorized into reporting, and you can see and they also don't know specific company rule about invoices, but they have learned the general pattern that the task with the words like can't log in, error message, and not working are usually bugs. Because over here we are showing 10,000, like for an example, like we are showing 10,000 past examples. So based upon that, the ML model catches the words like can't log in, error message, and not working are usually categorized under bugs. But they are great at handling view and wake requests because they are flexible, because it understands the nuance. So it can correctly guess the final, basically, if there is like finalize the Q4 analysis, then it is a reporting task, even without the word report is present over there. So it is flexible, it understands nuance, and it also learns, right? It can find complex patterns that we would never think to write a rule for. And it is scalable because it can handle thousands of different types of datas and tasks. And the cons for this is like, because like we need data, a lot of good and clean data is required for training. Black box, because it can be hard to explain why it made a specific prediction. It can be also wrong because it can be probabilistic, because it's making an educated guess, sometimes it will be wrong. And like why not both, right? So like our core strategy is like rules should be first. So we let the rule based engine, that is to check the task first. Then if it finds 100% definite match, so as you can see the hybrid system architecture, so over here we let the rules first. So then if it finds 100% definite match, like for example, like the word urgent is present, then it makes the call. And the ML model is never used. But if and only if the rule engines find no match and it says I'm not sure and passes the task to the ML model to handle the complex nuance stuff. So that's when the ML model comes in and does the work and final prediction is there. So this gives us the best of the both worlds. So the speed and reliability of rules for the important easy cases, and the intelligence and the flexibility as well for like of ML for everything else. So as we can see, like first it is checking the rules engine for keywords like invoice, password. So there is no keyword match, and it is passing the model to the ML model for general analysis. So as you can see, the model analyzes the generic text and predicts the category is bug over here, because the report is not loading and it shows an error. Now we'll see other example. So as you can see, in the rule engine only the match is found because the keyword password triggered a high priority rule. So that is why like the rule it is determined by the rules engine, because the password triggered a high priority rule and it is already present. Even for invoice, like where can I find my latest invoice? Because invoice is also there, so that's why the match is found and the keyword invoice triggered a high priority rule. And invoices determined by the rules engine, and category is billing because invoices are related to billing. So as you can see, the payment word triggered a high priority rule over here, and that falls under the billing because billing includes payment, invoice. So as you can see over here, also password is triggering a high priority rule, and that is also determined by the rules engine and falling under the login issue category. So as we can see, like over here, multiple words are there, right? Invoice and password both are written, but over here, like the rules engine will only catch the first word because it is programmed to find and apply that rule. So as you can see, like the first word is invoice, so that is why it triggered invoice. Rules are programmed to find like the first word itself, so that is why. And multiple words are present, so like for password it would have been a different category, but as stated, the rules engine found the invoice first because it is stated at first, so that's why it is falling under the billing category. So now we'll see. So as you can see, there is no invoice, payment, password, nothing is there. So of course, the rules engine did not work. So that's why it was as stated in the hybrid structure, like architecture. So if there is no match in the rule engines, then it goes to the ML model, right? So that's what it happened over here. So the task description is the submit button is grayed out and cannot click it. So as you can see, it is determining bug determined by the ML model. So as you can see, this is a journal question, right? So over here also there was no role engine match, so it went to the ML model. And as you can see, this is a journal request. So like it is a feature request because it is adding a feature, right? Because how do I add a new user to my team? So this is a feature request. Over here, the model is predicting this wrong because this should be also for like it should be feature request or suggestion should be there. So it is predicting it wrong over here. It should fall under the feature request actually. Because like it would be great if we export this data to a CSV file, right? So this is wrong because it predicted bug. So as you can see, this like at the step one, because it finds no keywords and the ML model analyzes the text spinning stuck and predicts bug. So as I've stated, ML model can be probabilistic as well. So it is predicting it correctly because the save button is stuck and it just keeps spinning. So bug is the right one for this one. This is also wrong because I think that it should not fall under bug because there the words are not indicating any like words like that is indicated towards the bug. I think this should be feature request. So this is also wrong that it is predicting. So this is a general question. So for this also it is predicting wrong because it should be basically fall under the user support or like how to because it is just like where do I find the settings to change my profile picture. So as I've said, the ML model can be probabilistic, but over here the new dashboard update is very confusing and hard to use. It is determining feature request, but I think it can be also classified under maybe user sub like user feedback or bug as well because it can be there because the new dashboard update is very much confusing. So that is why. So now we'll see how it is done. So first we need to make sure that we have all the tools that we need. So that is skitlearn and pandas is used for organizing our data into the table called data frames. So, like after inputting the libraries, we basically need to create our historical data set. That is the most primary thing that is needed to run. So, this is our collection of past help tickets. So, we just have text of the ticket and the category. So, it was just correctly sorted it. So, the label data is the textbook our ML model will study, right? So, as you can see, the data that we are creating. So the login button is broken down because it shows an error. Fix the password reset error and it is not working. As you can see, we are adding the data for this. And for categories, we have like bug, bug, bug. So we have sorted in that way only. And feature, like all, like we have just three categories, that is bug, feature, and billing. So then the step two would be to train the ML model. So here we are going to teach the model to find the general patterns. So the process is to vectorize, that means turn the text into numbers using TF-IDF, and then train and show the model the numerical text and the correct answers, right? So as you can see, like creating the vector to turn the text into numbers. So as you can see over here, X is the numerical features, that is the evidence, and Y are the labels, that are the correct answers. And we are using random forest. So this is a training mounted step. And then we would save the train components. So in a real application, you don't retrain the model every time, but you train it once and then save the brain, that model, and the vectorizer to the file. We use the job like library for this, and post that we need to build the hybrid classifier. So this is the main event. We'll create a new class that combines our two components, that is the rule engine and the ML model. So as you can see, it is done by hybrid task classifier. So a classifier that uses a rules engine first, right? Then falls back to the ML model. So when the classifier is created, it immediately loads the safe components. And as you can see, hybrid classifier is starting up. Then like we need to print loading vectorizer, loading ML model, and classifier is ready. So then we would define our unbreakable rules in a structured dictionary. So this is the specialist manager's rule book. So the self rules for billing, as you can see, invoice, payment, subscription charge, and bill is there. And for login issue, we have stated like password, cannot log in, reset my account, and logged out. And the rules are there. So if a rule is matched, then the return the category immediately. But if the loop finishes, then no rule was triggered. What if the model they did not find the keywords? So then it will be going to the ML model. So now we see we use the model for general purpose prediction. So we vectorize the new text using the same vectorizers the model was trained on. So we use dot transform, not dot fit transform, because the vocabulary is already learned, right? And then we get the main prediction of the model. So we try the specialist rule first. So rule prediction is successful, then no ML model is used, but if no rules are matched, then it falls back to the ML model. So that's how it is done. So post that, after that, then we will create our classifier object. So it will automatically load the files that we saved. That is done by this. And test case one, so it is a clear rule based task. So the task contains the one invoice, so which is in our rule book, right? So task one is like, I have a question about my invoice from last month. So the prediction method one is like, as we already have this, so it will be determined by the method one, right? But a clear ML based task. So this task has no rule keywords. So it should fall back to the ML model. So the main dashboard is not loading and it's showing an error. It should be determined by method two, that is the ML based. Test case three is another rule based, that is login. So this task contains the password word. So I need to reset my password. So this would fall under the method one, that will be the rule based. This is another ML based task, that is vague. So it would be cool to add a new color theme. So since it is vague and no keywords are detected, so it will fall under the ML. So as we have created the historical data set, you can see, and it was categorized into bug, feature, and billing. So as stated above, yes. So everything is categorized. So three features, three category features were there. You can see. So you can see the model was trained successfully, and by saving the trained components to the file. So it is saved. Then we are building the hybrid classifier class, that is using by hybrid task classifier has also been defined. So I have a question about my invoice from last month. So the match was found and it was handled by rules engine. For task 2, the main dashboard is not loading and it is showing an error. It is like over here, no keywords were found, so it is determined by the ML model and the prediction is bug. For this task, as you can see, I need to reset my password. So this task was handled by the rules engine because they found the word password, and the prediction is login issued, and that is determined by rules engine. The last task is that it would be cool to add a new color theme, that is like no rules match, right? So passing to the ML model for analysis, and it has predicted feature that is determined by ML model. So this is how this will be smart task prediction would be done. That is like by combining hybrid ML plus rules engine. So So this is how it will be done. So as you can see, the test case has been added over here, and like for the test case one also, you can see what it has predicted billing. So the prediction has been done correctly over here. So this will be for today. So did you guys get the files? So I have shared it to the support team. I hope they have shared it to you guys. Did you guys get the files or you did not get? Can anybody confirm upon that? Okay, so I'll be sharing today's file as well. This will be for today. Then we'll wrap up the session if no questions are there. So I'll be sharing this sample program as well, and you can learn how to basically do it. And that's pretty much about the smart text, like smart text prediction system. Basically, it is done by the class hybrid task classifier. Okay, then we'll wrap up the session for today. They will be sharing. So if your team is not responding, then you can do it individually. That's what I will like say you to do so. That will be better. If they're not responding, then you can do it individually. That's not a problem. So the project review will be happening soon, I think. Probably like at the end of this month, I suppose the project review will be there. For this, I think Susan, you need to ask to the support team because they have already categorized everybody into the group. That is why. Yes, you can select the data set by yourselves, and also select the projects by your choice, like out of three. That can be done. Yes, that totally depends upon you how you want to proceed and make your project. So that is there, right? So at the end, the project needs to be completed and submitted on the project review date. So you can do the weekly things that is mentioned in the project and coordinate up, but at the end the goal is to complete the project and submit it. Okay. Then if that's it, then we'll wrap up the session now. Then wrapping up the session now.